In this short video, we are going to have the proof of one corollary which states that if characteristic of f is p and f of x is irreducible and also f of x has multiple roots, then f of x should only be of the form g of x bar p for some g of x. Of course, p is a prime number. Now, we'll assume first that f of x has multiple roots. Then by the lemma, we have f of x and its derivative having non-trivial common factor. We shall call it as d of x. Remember, your f of x is irreducible, that is given here. So the only factors of f of x are 1 and f of x. And that happens to be, that has d of x as GCD. So that means there is no other go, your d of x has to be f of x. So f of x divides, because it is GCD, it has to divide in that f dash of x. Because degree of this is degree of the derivative is less than the degree of the original function, the only way f of x divides f dash of x is only if you have that to be 0. So now the question is, what are the polynomials with 0 derivative in f where characteristic of f is p? So for that we'll consider f of x to be this nth degree polynomial, and this is written in short form like this. Then when you find the derivative, we are differentiating with respect to x, so this is what you get. Now you are given f dash of x to be 0 here from here. So this in turn implies I into a power ai is 0 for all I ranging from 1 to n in f. Now with characteristic of fp. Now this is true for all ai, means I must be 0. When will I be 0? In characteristic of f, when you have f which has characteristic p. So this is nothing but, you can have I to be multiple of p. And this is just for convenience sake, we are denoting that integral multiple as that integer as mi. That's only for convenience sake we are now naming it as this. So when you consider this, this is x bar, you can write your x bar mi. You can write your x bar mi p as x bar p par mi. So you will have the whole lot to be a polynomial expression in this. So you have f of x to be g of x bar p. Thank you.